Hello everyone. Let us now discuss how can we solve this problem. Count the number of fair pairs. So we are given with a zero indexed integer array nums of size n and two integers lower and upper. Return the number of fair pairs. So a pair I comma j is fair if 0 is less than or is equal to I less than j less than n and lower is less than or equal to nums of I plus nums of j is less than or equal to upper. So what is given in the question is something like take pairs, wait a second, take pairs I comma j. So 0 should be less than or equal to I less than j less than n, where n is the size of array, and nums of I plus nums of j should be less than or equal to upper, and also lower should be less than or equal to nums of I plus nums of j. Now let us see what happens when you consider this one. Lower is less than or equal to nums of I plus nums of j is less than or equal to upper. Now what I am saying is consider only this condition and put this condition aside for a minute. Now I am considering nums of I plus nums of j should be less than or equal to upper and greater than or equal to lower. Now take this array 0 1 7 4 4 5. 01745. Now I am getting something like a pair, as we got 3 and 6 as lower and upper. Now I am taking a pair something like 1 and then 4 here, right? Now imagine instead of 4 here, I placed it as something like 0 1 4 4 5 7. That means I have sorted it. Now does this change our answer? No. 1, 4 are our same pairs again. So that's why here it will be I, here it will be J. Now you might think something like, what if we are going with an array like 0, 4, 7, 1, 4, 5. Okay. Now I am sorting the pair again. Then I'll get the same thing here 0 1 4 4 5 7. Now even then I get to this 4, and do I have anything to add to this 4? So I am considering this as I. Do I have anything as nums of j, so that I come in the range of lower and upper? So if I see 7, if I add it, I'll go to 11, so which is greater than upper. If I add 1, I'll be in the range which is 5, right? 4 plus 1 is 5 and it is a fair pair, so I am taking this one. But do I have, is there any need so that I don't or I should not sort this? No, because even if I consider this as I, even if I consider this as I and this as j, that's what I am doing here. This I am considering as I, this I am considering as j. Right? Now, this is the first observation for me. So, sorting does not affect here. Okay, now I have sorted this. Now let us see, lower is less than or equal to nums of I plus nums of j is less than or equal to upper. Let me take this array which is sorted. Now I am doing one thing. Yes, here I am taking 0. Okay, here I am taking 0. Now just remember that lower which is given to us is 3, and the upper which is given to us is 6. Okay, what does it mean? I need I comma j, the indices, not even indices. I need just the count. That's it. If we are asked with I and j, then sorting will not uh, work here. We should not sort them. Now I need count, not the pairs, right? Just remember this. I need the count of pairs, not the pairs. Okay. Now lower is 3, upper is 6. Now I have 0. What is the minimum number I can add and also the maximum number that I can add to 0? Then I will get the sum in the range of lower and upper. I'll write it here. What is the lower or lowest bound number that I can add and higher bound or upper bound number that I can add so that the sum will be in range of lower and upper. Okay. What is the lower bound number that I can add and upper bound number that I can add so that the sum will be in range lower and upper. Now let us see what I am doing actually. Nothing but here, take this lower which is 3, take this upper which is 6. Now what is the number that lowest bound that I need to add to 0 so that I will get in the range of lower and upper. Now if I add 3, then I will get in the range lower and upper, right? So if I add 0 plus 3, I will be getting 3. Now I have upper which is 6. So instead, why should I go and add 3? Instead, I just do something like, instead of doing something this, I will do lower minus nums of I, which I am iterating now. Lower minus nums of I will give me the lowest bound. Upper minus nums of I will give me the upper bound. Now, remember this and let us take the count of elements which comes in this range. Not this range 3 and 6. Don't get confused. We will get another numbers instead of 0. So don't get confused that we are searching for lower and upper. No, we are searching for lowest bound and upper bound. So lowest bound number, upper bound number. Now let us see 3 and 6. Okay, I have 1. Do I have to consider it? No. Why? Because it is lesser than the lower bound. So I am not considering this. Okay. 4. Do I Can I consider it? Yes. Why? Because if I add 4 and also 5, so that I will get in this range. This is what this lower bound and upper bound makes sense, right? Lower bound and upper bound, lower bound and upper bound are, wait a second, bound are nothing but just the number range that we can add to nums of I, so that the sum will be in range of lower and upper, right? So this is what the lower bound and upper bound indicates. Now I have 4. Okay, 0 plus 4 will come in this range, right? That's why I am searching, instead of going to lower and upper by taking the sum, I am checking the numbers which comes in this range, lower bound and upper bound, right? 4 is in the range. Okay, I am considering it. 4 is again in the range. Okay, I am considering it. 5, is it in the range? Okay, I am considering it. 7, is it in the range of lower bound or upper bound? No. Okay, I got an answer. Count will be 0 initially, but now I got 3 pairs. 0, 4, 0 plus 4 will be in this range. Okay, let us see. Now 0 plus 4, which is 4, will come in this range, lower and upper. 0 plus 4 again, which comes in this lower and upper. 0 plus 5, which is 5, which comes in this range. Okay, that means I have lower count is equal to 3 with 0. Now let me remove all this stuff, right? Okay. Now I have changed the number. That's it. I have changed number. That's why I'm just going to 1. Okay. Now I have 1. Okay, I have 1. Now I do the same thing. Lower minus 1, upper minus 1. Let us see what happens. Lower is 3. 3 minus 1, 2. Upper is 6. 6 minus 1, 5. Okay. 2 and 5. Let us see. Do I have a 2 before my 1? Do I have it? No. Why? Because 2 is always greater than 1. If you remember, lower is 3 and upper is 6. The difference of 1 will be always greater than 1 when lower is greater than 1. I will also tell you when lower is lesser than nums of I. I'll also get to this condition, but wait a second. 1 is nums of I and lower minus nums of I will be greater than nums of I. I am assuring you that. Now, okay, this is my lower bound and this is my upper bound. I need to count by these values. Now, I will not count at this index which is lesser than nums of I. I'll only consider this as I said. Lower bound will be greater than nums of I. Upper bound will also be greater than nums of I. So, why should I search at these indices which are lesser than nums of I? No, there is no need. So, that's why I only consider searching from I plus 1 till n minus 1. So, okay, 2. Okay. Now I have 4. Will 4 comes under 2 and 5, between 2 and 5? Okay, it will come. Okay. Now I am considering 4. Now I have another 4. Will 4 comes between nums lower bound and upper bound in the range lower bound and upper bound? Yes. Will 5 comes in the range lower bound and upper bound? Yes, consider it. Will 7 comes under lower bound and upper bound range? No, I am not considering it. Now, what are the number of pairs that I get? With 1, I'll tell you, with 1, I got 1 and 4. The sum is 5. Let us see. 3 and 6. Between this, I'll get 5. Okay. 1 and 4. 5. So, this comes in this range. 1 and 5. 6, which is in the range. Okay. That means I have 3 another uh, fair pairs. Okay. Now, let me remove this here from here. Okay. Now, the number is changed. That's why I'll do one thing. Let us take 4 now. I am going to here 4 and I need to search the lower bound and upper bound here. Now, 4 is the number and the lower bound is 3. 3 minus 4 is minus 1. Upper bound is 6. 6 minus 4 is 2. Okay. There is a conflict, right? I have minus 1, I have 2. Now I have minus 1, now I have minus 2. I need to check, do I have any numbers in the range of minus 1 and minus 2 after this element? Absolutely no. Why? Why? Because the 4 is even greater than the upper bound, right? How do you get these these elements after 4 which are like 0 and 1? How do you get this? But you might say, bro, I got this 0 and 1 previously. Why shouldn't I count the whole array? That's why, bro, I started iterating from I plus 1. If you remember, I even you're right that from 0 I get this 4. That's why at 0 I have counted with this one and I got 0 and 4 as a pair if you remember, 0 and 4 as another pair if you remember, 0 and 5 as another pair if you remember. And you have also asked me, right, 1 will be also another pair. That's why I have also counted the subarray from I plus 1, I got, if you remember, 1 and 4, 1 and 4 again, 1 and 5 again, but I didn't took this 7, if you remember, just before. Okay, that means we are going in the right direction, and if we have minus 1, no need to worry, just let go. Okay, I have 4 and this one, just let go. Now I have this 4 again. Now I'll get the same minus 1 and 2. Just let go. I'll tell you what I'll do here. I'm just saying that just let go, right? 5. Now I have 5. 3 minus 5 is minus 2. Upper is 6. 6 minus 5 is 1. Do you consider this minus 1 and 0 will be present after this in this subarray? No, absolutely no. That means there will be no elements. I'll tell you what it will be returning also, what our function will be returning also. Now let go. Okay, just let go. Now 7, right? Do I have any subarray after this 7? No, so no need to consider it. Now take this 0 ones. Okay, take this 0 ones. What we are doing actually here, I am taking 3 minus 0, 6 minus 0. Okay, this is the range that I need to search. So I took this subarray from I plus 1. Now what I'll do is take lowest number which returns the index and higher number which also returns the index. Now lowest number binary search, right? Binary search will do something like, okay, 1 which is in the range, no, go to the next element, 4 which is in the range, okay, this is my lowest number. Now 7 which is greater than lowest highest number, but in the function it will go from the beginning, right? 1 which is lesser than higher, so skip it. 4 which is lesser than this 6, so skip it. 4 again which is lesser than 6, so skip it. 5 which is lesser than 6, so skip it. 7 which is first time greater than 6, right? So this will be my upper. So what we need to do, just count plus is equal to upper minus lower, as upper will give the highest number after the range. That's why I am taking upper minus lower. That means it is counting just these 3 elements, right? And if imagine something like 7 is also in the range, then upper will be after this. Okay, that's how the binary search for this work. Now as I am saying, lowest number will be coming like lower bound, right? Lower bound of nums dot begin plus I plus 1. That means I am searching after the current index I, right? Nums of I plus 1 until nums dot end. Okay, nums dot end. And what I am searching for, I am searching for I think low number. Let me name it as low number, and I am removing nums dot begin. Okay, this is how the lowest number will be, and highest number will be upper bound of nums dot begin plus I plus 1 comma nums dot end comma high number. High number is nothing but this number. So remember that this number is lower number, this number is high number, right? High number minus nums dot begin. Why I am removing this nums dot begin? Because this lower upper bound is nothing but an iterator, right? Which is an iterator, and if I remove nums dot begin, then I'll get index where the highest number is. Okay, for now let me write the algorithm. Now the algorithm will be starting with starting with sort the array, and then I'll do something like for I is equal to 0, and I'll be going till n and I plus plus, right? Now let us see num is equal to nums of I. Okay, the low number will be lower minus nums of I. High number is upper minus nums of I. Now I need something like low number and high number. Now I need lowest bound and highest bound. So L is lower bound. As I said, this will be copied. So instead of lowest number and highest number, I need to take L and U. So I'm just copying it and just pasting it here. So L will be lower bound, right? I got this. Now count plus is equal to, if you remember, upper minus lower will give you the answer return counted. Then don't forget to initialize count is equal to 0 if you are C++ or Python user. So long count is equal to 0, as the count can be large. Right, this is the code. I have given the code link in the description. Go and check it. If you like this video, do share it with friends and do subscribe to my channel. Thank you.